July 14, 1944. 6 kilometers southeast of Caen, France. His voice tight with controlled alarm. Black smoke poured from the engine deck behind his commander's cupola. Not the usual diesel haze, but thick, acrid clouds that meant catastrophic failure. The transmission had been grinding for 3 days, a sound every experienced Panzer commander knew preceded disaster, but the maintenance crews were 40 kilometers behind the front, still working on tanks disabled a week ago. Müller's driver, Gefreiter Klaus Werner, felt the engine seize through his controls, the massive Maybach HL-230 dying with a grinding shudder that traveled through the hull. They'd been advancing across an open field toward a tree line where American reconnaissance units had been spotted at dawn. Now they sat motionless, 800 meters from cover, with the distinct whistling sound of incoming artillery already audible over the radio chatter. Werner hammered the starter twice, knowing it was futile, watching oil pressure drop to nothing on gauges that would give him nightmares if he survived the next hour. The crew bailed out with practiced speed, each man knowing their disabled tank had transformed from predator to monument, a 50-ton target for every American artillery observer within 10 kilometers. Müller's grabbed the crew's personal weapons and maps, leaving behind the precisely engineered beast that had taken German workers 3 months to build. His gunner, Unteroffizier Paul Richter, took one last look at the fire suppression system indicator, red light glowing, meaning the automatic systems had already failed. The Panther's engine compartment design required complete disassembly to access major components, a job that took specialized equipment and a minimum of 48 hours in a rear area workshop.
They sprinted toward a drainage ditch 200 meters east, rounds already impacting near their abandoned vehicle. Müller counted the seconds, knowing recovery vehicles wouldn't reach them before dark, if they came at all. He'd seen 6 Panthers from his company alone sitting disabled behind the lines, waiting for parts that might never arrive from factories in Germany now being bombed around the clock. The tank they'd just abandoned represented irreplaceable resources, manganese steel that Germany no longer had in abundance, a complex gearbox that required precision machining, an engine whose tight tolerances made field repairs nearly impossible. As they reached the ditch, Müller turned back to watch an American Sherman's 75mm round punch through the Panther's side armor, exploiting the angle. The tank didn't explode, simply sat burning, its sophisticated engineering now worthless. He'd heard from other commanders about the American maintenance operations, rumors that seemed impossible, talk of complete repairs happening in minutes rather than days. But Müller had dismissed those stories as propaganda or exaggeration, the desperate fabrications of an army trying to explain how they kept losing ground to technically inferior machines. The recovery Panther arrived 17 hours later, just after dawn on July 15th. Müller and his crew had spent the night in a hastily dug foxhole 400 meters from their destroyed tank, watching American patrols probe the area, listening to the continuous rumble of vehicles moving on the roads behind enemy lines. The recovery vehicle's commander, Hauptmann Ernst Vogel, climbed down with news that made Müller's stomach tighten. 3 more Panthers had thrown transmissions during the night withdrawal, and 2 Panzer IVs had engine fires. The battalion's effective strength had dropped to 11 operational tanks from the 29 they'd started with 5 days ago. Vogel walked around the burned-out Panther, shaking his head at damage that extended beyond the American hit. The engine seizure had cracked the mounting frame, and heat from the fire had warped components throughout the rear compartment. Even if they could tow it back to the mobile workshop, the repair would require parts that didn't exist in France anymore. The Maybach engine alone weighed over a ton and sat integrated into the hull in a way that required removing the entire rear deck, disconnecting hundreds of components, and using overhead cranes that only existed in permanent facilities. Vogel had watched his mechanics work 72-hour shifts trying to keep tanks operational, men falling asleep with wrenches in their hands, and still the numbers kept dropping. They hooked towing cables to the Panther's hull, and the Panther's winch strained against the deadweight. The journey back to the workshop area took 4 hours. crawling at walking speed through roads cratered by American fighter bombers, past burning supply trucks and exhausted infantry. Moeller rode on the Panthers' deck, watching the countryside and thinking about his driver Werner's comment from the night before, that they'd lost more tanks to mechanical failure than to enemy action in the past month. It was the kind of observation that could get a man sent to a penal battalion if the wrong officer heard it, but Moeller knew it was true. The mobile workshop sat hidden in a forest clearing, a collection of half-tracks, tool trucks, and canvas-covered work areas where 20 mechanics labored over 5 disabled Panzers in various states of disassembly. Oberleutnant Friedrich Hoffmann, the battalion's chief maintenance officer, looked at Moeller's burned Panther and made a quick decision. It would be cannibalized for parts. The transmission could be salvaged for another tank if they could get it out, a job that would take 2 men 3 days of work. The road wheels, still intact, were desperately needed, but the engine was a total loss and they had no replacements. The closest depot with Maybach HL-230 engines was in Stuttgart, 500 kilometers away, and probably being bombed as they spoke. Hoffmann led Moeller to a tank that had been sitting in the workshop for 11 days, its entire rear deck removed, engine hanging from a hand-operated crane rig the mechanics had improvised from captured equipment. 4 men were working on it, their faces hollowed with exhaustion, hands black with grease and cuts from sharp metal edges. They'd managed to extract the engine, a process that required disconnecting fuel lines, electrical systems, cooling systems, the exhaust, the drive shaft, removing dozens of access plates and structural components. Now they were waiting for a replacement crankshaft that might arrive in a week, or never. The tank sat useless, representing hundreds of man-hours of precision engineering, defeated by a single failed component and a supply system that couldn't keep pace with attrition.
Muller watched a young mechanic, barely 18, struggling with a wrench nearly as long as his arm, trying to loosen a bolt that had seized from heat stress. The boy had been working since yesterday morning, Hoffmann explained, and wouldn't stop until he collapsed or the job was done. This was how Germany's vaunted Panzer force was dying, Muller realized, not in glorious combat, but in muddy clearings where exhausted mechanics fought losing battles against entropy and over-engineered complexity. He thought again about the rumors of American maintenance operations, and for the first time allowed himself to believe they might be true, because if they weren't, the Americans wouldn't still be pushing forward, while German armor sat immobilized in forests. July 16, 1944, 3 kilometers west of Saint-Lô, France. Technical Sergeant Robert Chen felt the Sherman M4A3 shudder beneath him before he heard the sound, a deep metallic clunk from somewhere in the drivetrain that made his teeth ache. Lieutenant James Morrison, commanding the tank they'd nicknamed Rolling Thunder, immediately signaled the platoon to halt, his hand rising through the commander's hatch in the gesture every tank crew dreaded. Chen, crouched in the driver's position, ran through his mental checklist while monitoring the gauges. Oil pressure steady. Temperature climbing but not critical. The clunk came again, louder this time, and he felt it through the floor plates. Something in the transmission or final drive had failed. Morrison's voice came through the intercom, calm and procedural, ordering the crew to shut down and prepare for recovery. There was no panic in his tone, no sense of catastrophe, just the mild annoyance of a broken tool that would need fixing. Chen guided the Sherman off the road into a farm gateway, positioning it where the recovery vehicle would have clear access. The engine died with a simple twist of the key, and suddenly the relative quiet of the French countryside replaced the constant mechanical thunder they lived inside. Corporal Eddie Martinez, the gunner, was already on the radio calling for maintenance, giving their grid coordinates and a preliminary damage assessment. The recovery M32 arrived 47 minutes later, its crane boom folded down against the hull, Sergeant First Class Thomas Burke riding in the commander position with a clipboard and the calm expression of a man who'd seen this situation 100 times. Burke's crew chief, Corporal Jimmy Patterson, was already pulling engine covers before the M32 came to a complete stop, his movements showing the efficiency of countless repetitions. Burke walked around Rolling Thunder once, knocking on the drive sprocket housing, listening to the sound, then nodded to himself as if confirming a diagnosis.
Final drive failure, he told Morrison. Probably the reduction gear. They'd tow it back to the maintenance company and have it running again by tomorrow morning. Chen climbed out and watched Burke's crew work with fascination he'd never quite lost despite 6 months in France. They connected tow bars with quick-release pins, checked the Sherman's transmission for the tow, and had Rolling Thunder hooked up in under 15 minutes. The journey to the maintenance area took 30 minutes, passing 2 other Shermans heading back toward the front, freshly repaired, their crews waving as they passed. Chen counted 8 operational Shermans from their company staged near the road, waiting for orders, and realized with a start that he couldn't remember the last time more than half their platoon was down for maintenance at once.
The 3rd Armored Division's forward maintenance company occupied a commandeered farm compound 2 kilometers behind the line, a sprawling operation that looked more like a factory than a military camp. 6 Shermans sat in various stages of repair, but unlike the desperate, chaotic German workshop Moeller had witnessed, this place hummed with organized efficiency. Specialized tool sets hung on pegboards under camouflage netting. Prefabricated engine hoists stood ready. Stacks of crater replacement engines sat under tarps, each one a complete Ford GAA V8 power unit already mounted on its subframe, ready to drop into a hull. Technical Sergeant William Foster, the maintenance platoon leader, directed traffic with hand signals, routing disabled tanks to specific work bays where crews already had tools laid out. Burke positioned Rolling Thunder next to a concrete pad where an overhead hoist had been rigged from captured German equipment and American ingenuity. Foster walked over, listened to Burke's assessment, and checked his clipboard. They had the parts, a complete final drive assembly, or they could swap the entire power pack if the damage extended further. Morrison asked how long the repair would take, and Foster looked at his watch with the casualness of a man checking the time for lunch. If it was just the final drive, they'd have Rolling Thunder back by 1800 hours, about 7 hours. If they needed to do a full engine swap, add another hour, maybe 90 minutes. Morrison absorbed this information with a nod, as if someone had just told him his laundry would be ready by Tuesday, and walked off to find hot coffee and a situation briefing. Foster's crew started the preliminary inspection at 0945 hours, and by 10:15, they'd confirmed the final drive could be saved, but the transmission had suffered secondary damage from metal fragments. The decision came quickly: complete power pack replacement, the procedure that made American tank maintenance a logistical revolution wrapped in grease and American pragmatism. Staff Sergeant Leonard Woods, the crew chief for this bay, had performed this operation 63 times since landing in Normandy 6 weeks ago. His 6-man team moved with the synchronized precision of an assembly line, each man knowing exactly what tool came next, which bolt sequence prevented mistakes, where every component needed to be before the next step could begin. Private First Class Joseph Kowalski and Private Daniel Hayes disconnected the electrical systems first, their hands moving through the engine compartment like surgeons, unplugging connectors that had been designed with maintenance in mind. Every wire harness had quick disconnect fittings. Every gauge line could be removed with simple hand pressure. The Ford GAA engine hadn't been engineered for maximum power or sophisticated performance. It produced 450 horsepower compared to the Panther's 700. But every component had been designed with a single question in mind: how fast could a crew remove and replace this in a muddy field under artillery fire? Corporal Marcus Thompson and Technician 5th grade Robert Sullivan worked the cooling system, draining fluid through valves positioned for rapid access, disconnecting hoses held by spring clamps instead of traditional bolts. The entire coolant system could be isolated in under 3 minutes. Fuel lines came next, with self-sealing disconnects that prevented spillage and fire hazards. Sullivan called out the steps like a verbal checklist, and Thompson confirmed each one, their rhythm established through repetition that made thought unnecessary. Above them, Woods operated the hoist controls, positioning the lifting frame that would cradle the entire power pack, engine, transmission, and final drives, all mounted as a single removable unit. The power pack itself sat on 4 main mounting points, massive bolts that carried the weight and stress of combat operations, but could be accessed from above and removed with standard wrenches, no specialized tools required. No need to disassemble half the tank to reach critical fasteners. Woods' team had the mounting bolts out in 8 minutes, working in pairs, each team synchronized to maintain even pressure and prevent binding. The exhaust system disconnected with 4 more bolts, the entire assembly designed to swing clear. The drive shaft separated with a collar clamp. Every connection point had been engineered for exactly this moment.
not for elegance or sophistication, but for a maintenance crew working against the clock. At 10:37 hours, 22 minutes after they'd started the actual removal, Woods gave the signal and operated the hoist. The entire power pack, 1,200 pounds of engine, transmission, and mounting frame, lifted smoothly out of Rolling Thunder's hull as a single unit. The crane swung it to the side where Kowalski and Hayes guided it onto a maintenance dolly, and the extraction was complete. The Sherman sat there with its engine compartment exposed, looking less like a crippled war machine and more like a piece of industrial equipment ready for its scheduled maintenance interval. Chen, watching from near the coffee station, saw 4 other Shermans in the compound at various stages of this same procedure and realized he was witnessing an assembly line running in reverse and then forward again.
The replacement power pack sat ready on its own dolly, a fresh 4 GAA that had been built in a Detroit factory 3 weeks ago, shipped across the Atlantic, and trucked to this farm in France as part of a supply system that treated engines like ammunition: consumable, replaceable, abundant. Wood's crew rolled it into position, and the installation began with the same choreographed efficiency as the removal. The power pack lowered into the hull. Mounting bolts threaded in by hand first to ensure alignment, then torqued down to specification with calibrated wrenches. Drive shaft connected. Exhaust system bolted up. Fuel lines, cooling lines, electrical connectors, each system reconnecting in minutes. The design philosophy of modularity making every step straightforward. At 11:09 hours, 32 minutes after they'd lifted the damaged power pack out, Woods turned the key and the replacement engine roared to life. He ran it through a quick diagnostic check. Oil pressure good, temperature rising normally, transmission engaging smoothly through all gears. Rolling Thunder was operational again. The entire repair completed in 94 minutes from arrival to engine start. Morrison walked back from his briefing, coffee still warm in his hand, and looked genuinely surprised they'd finished so quickly. Foster marked the completion time on his clipboard, already moving on to coordinate the next repair, treating a complete engine swap with the same administrative attention as a routine oil change.
July 18, 1944. American POW processing area, 12 kilometers northwest of Saint-Lô. Oberfeldwebel Heinrich Müller sat on a wooden bench in the shade of a camouflage net, his uniform jacket stripped of insignia, his Iron Cross tucked away in a pocket where the Americans wouldn't confiscate it as a souvenir. He'd been captured 2 days ago when his makeshift infantry position was overrun by American tanks, Shermans, naturally, appearing in numbers that seemed impossible given how many his unit had claimed destroyed. 37 German tankers sat in this compound, men from 6 different Panzer units, all waiting to be transported to a rear area detention facility. None of them looked particularly concerned about their fate. After weeks of mechanical breakdowns, dwindling supplies, and watching their technical superiority mean nothing against American abundance, capture felt almost like relief. The American guards were relaxed, almost casual, smoking cigarettes and sharing rations with prisoners who asked politely. One guard, a corporal whose name tape read Williams, spoke broken German and seemed genuinely curious about the Panthers and Tigers these men had crewed. Moeller answered carefully, sticking to technical details that weren't classified, describing the Panther's excellent gun and armor, while carefully omitting its tendency to burst into flames or throw transmissions. Williams listened with interest, then pointed toward a collection of buildings 400 meters away where Moeller could see tanks moving. That was a maintenance company, Williams explained, where they fixed broken Shermans. He said it with the same pride a factory worker might describe a production line.
Around 1400 hours, a convoy of damaged Shermans rolled past the compound, and Mueller watched with professional interest as they headed toward the maintenance area. 3 tanks, various states of damage, one with obvious transmission trouble, judging by the tow cables, another with battle damage to the turret, a third trailing smoke that suggested engine problems. Unteroffizier Paul Richter, Muller's former gunner, nudged him and made a quiet joke about how the Americans would need a week to fix that mess. Several other German tankers chuckled, their laughter carrying the bitter edge of men who'd spent too many days waiting for parts that never came. Williams overheard them and smiled, saying something in English that Muller didn't catch. Then he gestured for them to follow him, apparently deciding that showing off American maintenance capabilities would be good for morale. Theirs, not the prisoners. A lieutenant gave permission with a shrug, and suddenly Muller found himself walking toward the maintenance compound with 15 other former Panzer crewmen, guarded by 3 American soldiers who seemed more concerned about the prisoners seeing something interesting than about security. The war had that strange quality sometimes, moments where enemies became simply men looking at machines, professional soldiers with more in common than the flags they served.
They reached a vantage point on a small rise where they could observe the maintenance company's operations clearly. What Muller saw made him stop walking, his engineering background struggling to process the scene below. 4 Shermans sat in workbays, and every single one had its engine deck open, power packs in various stages of removal or installation. Crane rigs swung complete engine assemblies through the air like children's toys. Mechanics moved between tanks with purposeful efficiency, no wasted motion, no apparent confusion or delay. He watched one crew, 6 men working with tools that looked mass-produced rather than specialized, lift an entire engine out of his Sherman in what couldn't have been more than 20 minutes. Richter muttered something that sounded like a prayer or a curse, his eyes fixed on the same scene. Gefreiter Klaus Werner, Muller's former driver, actually laughed, a sound that bordered on hysteria. He'd spent 11 days helping mechanics try to extract a Maybach engine from a Panther, work that required cutting through structural elements and improvising lifting equipment, only to give up when they realized the engine block itself had cracked and no replacement existed within 300 kilometers. Now he was watching American crews pull engines like mechanics changing tires, the entire Sherman powertrain designed to come out as a single unit, no disassembly required, no specialized equipment beyond a basic hoist. Hauptmann Ernst Vogel, the recovery vehicle commander who'd retrieved Muller's destroyed Panther, stood beside them with his arms crossed, his face showing the expression of a man whose entire worldview was being dismantled. He'd spent 2 years as a Panzer maintenance officer, had overseen the repair of dozens of tanks, knew the Maybach HL-230 engine manual by heart. The complexity of German tank engineering had been a source of pride. Sophisticated gearboxes, precisely machined components, engines that represented the peak of European engineering. Now he was watching American mechanics treat engines as disposable components in a system designed not for excellence, but for continuous operation. One of the Shermans below started up, its fresh engine running smoothly, and Vogel checked his watch without thinking. 75 minutes since that tank had arrived. Impossible, except he was watching it happen. The differences had been built into the tanks from the moment engineers first put pencil to paper, decisions made in Detroit offices and German design bureaus that would determine the war's outcome as surely as any battle. In 1941, when American engineers at Chrysler's tank arsenal began working on the M4 Sherman design, they brought automotive industry thinking to military problems. Henry Ford's assembly line revolution had taught American manufacturers a fundamental lesson. Complexity was the enemy of production, and maintenance downtime was lost profit. The Sherman's Ford GAA engine started as a failed aircraft engine design, converted to tank use not because it was sophisticated, but because Ford could manufacture it in quantity, using existing tooling and workers who understood automobile engines. Every component in the Sherman had been designed with the question, what happens when this breaks in a field 2,000 miles from a factory? The answer shaped everything. Quick disconnect fittings instead of permanent joints, standardized bolt sizes that meant a crew needed only a dozen common wrenches instead of specialized tools, a power pack mounted on a subframe that could be lifted out as a complete unit, eliminating the need to disconnect hundreds of individual components. The transmission bolted to the engine before installation, tested as an assembly, meaning field crews never had to align drive shafts or adjust complicated linkages. It was engineering that valued function over sophistication, designed by men who understood that wars were won by keeping equipment running, not by building the perfect machine. German engineers had approached tank design from the opposite direction, bringing precision manufacturing philosophy and a belief in technical superiority that went back to pre-war racing cars and locomotives. The Panther's Maybach HL-230 engine represented sophisticated engineering, aluminum alloy construction to save weight, precisely balanced components for smooth operation,
advanced fuel injection that provided better efficiency. But that sophistication came with costs that didn't appear on specification sheets. The engine sat integrated into the hull structure, surrounded by other systems, accessible only by removing the entire rear deck and disconnecting systems in a specific sequence that required training and experience. A cracked engine block couldn't be simply replaced. It meant rebuilding major hull components, work that required specialized facilities. The transmission design differences told the same story. The Sherman's 5-speed unit was simple, almost crude by German standards, but it could be removed and replaced by disconnecting 4 main mounting points. The Panther's sophisticated gearbox, with its 8 forward speeds and precision synchronizers, sat integrated with the final drives in a way that required removing and reinstalling dozens of components to access. German engineers had optimized for performance, creating transmissions that could handle the Panther's weight and power with mechanical elegance. American engineers had optimized for replaceability, designing transmissions that could be swapped by trained mechanics in a few hours rather than requiring specialists with workshop facilities. The maintenance philosophy extended through every system. The Sherman's electrical system used standardized components, the same generators, starters, and switches that appeared in trucks and Jeeps, meaning the supply system could stock common parts that served multiple vehicle types. The radio equipment came from the same manufacturer who made civilian broadcast gear, using vacuum tubes and components that American technicians understood from fixing home radios. German tanks used sophisticated, purpose-built electrical systems with components manufactured specifically for military use, technically superior but requiring specialized parts that couldn't be substituted or improvised. When a German radio failed, it needed German replacement parts shipped from German factories. When a Sherman radio failed, creative mechanics could sometimes cannibalize civilian equipment to get it working. The production numbers reflected these design choices in stark terms. Detroit's tank factories produced Shermans using automotive industry methods, standardized assembly lines, interchangeable parts, quality control that accepted good enough instead of demanding perfection. By July 1944, American factories had built over 40,000 Shermans, with production continuing at nearly 2,000 per month. German factories, requiring skilled craftsmen and precision manufacturing for their more sophisticated designs, had produced roughly 6,000 Panthers by the same date, with production rates hampered by bombing, material shortages, and the simple fact that complex machines took longer to build. The Americans could afford to treat engines as consumable items because they had the industrial capacity to manufacture replacements faster than combat could destroy them. Miller stood on that rise watching American mechanics work and understood with sudden clarity why his unit had been retreating for weeks despite winning most tactical engagements. The Panthers had better guns, better armor, better power-to-weight ratios. Every technical specification favored German engineering. But specifications meant nothing when half the battalion sat immobilized waiting for repairs that would take days or weeks, while American units maintained operational rates above 80% by simply swapping broken components for fresh ones trucked in from factories that operated 3 shifts per day. Germany had built superior tanks. America had built a superior system. And systems, Muller was learning, won wars that individual machines could not.
The strategic mathematics had been working against Germany since before the first Sherman landed in Normandy. Equations written in maintenance hours and operational readiness rates that no amount of tactical brilliance could overcome. In a typical American armored battalion in July 1944, 77 Shermans carried on the roster would see 65 to 70 operational on any given morning. Readiness rates between 95 and 90% that reflected the maintenance system's ability to return damaged tanks to service faster than combat could disable them. Forward maintenance companies kept tanks running with quick repairs, evacuation companies handled battle damage, and depot facilities in the rear rebuilt total losses. The system functioned like a circulatory system, damaged equipment flowing back, while repaired machines flowed forward in a continuous cycle.
German panzer battalions told a different story in their morning reports, numbers that grew grimmer as the campaign progressed.
A Panther battalion authorized 76 tanks might field 40 operational vehicles on a good day, dropping to 25 or 30 as mechanical attrition accumulated faster than workshops could address it. The problems compounded. Tanks waiting for parts sat immobilized, making them vulnerable to air attack or forcing their abandonment during retreats. Crews became demoralized watching sophisticated machines defeat themselves through complexity. Maintenance personnel worked to exhaustion and still fell further behind, their sophisticated training useless without the components and facilities their procedures required. By late July, some Panzer units reported operational rates below 40%, not from American action, but from the grinding accumulation of mechanical failures that couldn't be fixed in time. The time differential created cascading effects that changed the character of mobile warfare. An American tank company that lost 3 Shermans on mechanical failure on Monday could expect all 3 back in service by Wednesday, the maintenance system treating breakdowns as routine events requiring routine responses. A German Panzer company losing 3 Panthers to mechanical failure faced a different reality: weeks of waiting for parts, days of complex repairs once parts arrived, and the statistical probability that at least one tank would never return to service because damage exceeded field repair capabilities. This meant American units could plan operations assuming their equipment would function, while German commanders had to account for attrition that happened without enemy contact.
Staff Sergeant Leonard Woods kept informal statistics in a notebook he'd started in Normandy, tracking every Sherman his maintenance crew worked on, with the attention to detail of a man who understood he was witnessing something historically significant. In 6 weeks, his 6-man team had performed 41 complete power pack swaps, averaging 93 minutes per swap. They'd replaced 37 transmissions, repaired 62 track assemblies, and handled hundreds of minor mechanical issues. The damaged power packs didn't disappear. They went to rear depot facilities where specialized teams rebuilt them using factory techniques, returning them to the supply system as zero-time units ready for another installation. The system created a circular flow where nothing was truly discarded, just cycled through different levels of repair until it could return to combat. The fuel consumption mathematics added another dimension to American advantages. The Sherman's Ford GAA engine was neither efficient nor sophisticated, consuming roughly 160 gallons per 100 miles of operation. Terrible by civilian standards, but acceptable in a system where fuel supply had been prioritized from the invasion's first day. German tanks achieved better fuel efficiency on paper, but that efficiency meant nothing when fuel convoys were being destroyed by American fighters and the synthetic fuel plants in Germany were being systematically bombed. Panthers that could theoretically travel 125 miles on internal fuel sat immobilized because the sophisticated fuel they required wasn't reaching frontline units. Shermans ran on the same gasoline that powered trucks, jeeps, and generators, simplifying the entire logistics chain. The armor quality debate missed the same fundamental point. German tanks used face-hardened steel that offered superior protection per thickness, sophisticated metallurgy that represented advanced material science. But producing that armor required manganese, nickel, and molybdenum that Germany's shrinking industrial base couldn't supply in sufficient quantities. American armor used simpler, rolled homogeneous steel, easier to manufacture and form, supplied by steel mills working at full capacity without material constraints. The protection per pound favored German engineering, but American tanks existed in numbers while German production struggled to replace losses. A technically superior tank sitting in a factory waiting for alloy steel couldn't stop American advances, no matter how impressive its ballistic properties. Mueller had access to a German intelligence summary in the POW compound, a document someone had failed to confiscate, and he read the numbers with the growing understanding of a man whose beliefs were being systematically dismantled by mathematics. American tank strength in Normandy had grown from roughly 2,000 at D-Day to over 3,500 by late July, despite continuous combat losses. Replacements arriving faster than attrition could reduce the total. German Panzer strength in the same period had declined from approximately 1,500 tanks to under 800 operational vehicles, losses from both combat and mechanical failure exceeding the replacement rate by factors that made the trend line unmistakable. The Americans were getting stronger while Germany grew weaker.
and maintenance efficiency was as responsible for that divergence as factory production or tactical victories.
August 1944 arrived with the kind of brutal clarity that ended debates about technical superiority to the simple mechanism of exhaustion and numbers. Oberleutnant Friedrich Hoffmann, the maintenance officer Meller had spoken with weeks ago, sat in the ruins of what had been a mobile workshop, surrounded by 7 Panthers in various states of disassembly that would never be completed. The retreat from the Falaise pocket had forced the abandonment of tanks that might have been salvageable given time and parts that didn't exist. His mechanics had worked until American tanks appeared on the horizon, then destroyed what they couldn't save and fled east with hand tools and technical manuals, leaving behind months of accumulated work and the sophisticated machines they'd tried desperately to keep running. Hoffmann had stopped sleeping more than 3 hours a night sometime in July, his body running on coffee and the desperate energy of a man watching his professional world collapse. The notebook where he tracked maintenance operations told the story of compounding failure, repair times stretching longer as parts grew scarcer, operational rates declining despite his crews working 20-hour days, and the growing gap between the theoretical capability of German armor and the practical reality of machines that spent more time disabled than fighting. He lost 6 mechanics to exhaustion-related accidents, men who'd fallen asleep while working on dangerous equipment, and 3 more to American air attacks on workshop areas that were supposed to be camouflaged, but apparently showed up clearly on reconnaissance photos. The American maintenance system, meanwhile, had evolved into an industrial operation that looked less like military logistics and more like the automotive service infrastructure of a modern city. By August, Ford maintenance companies had refined their procedures to the point where standard repairs followed printed checklists, timing standards, and quality control measures borrowed directly from Detroit assembly plants. Technical Sergeant William Foster's company had processed over 400 Sherman through various repair levels since landing in France, maintaining flow rates that kept 3 armored battalions operational despite continuous combat. His crews worked in shifts, fresh mechanics replacing tired ones, maintaining 24-hour operations without the desperation that characterized German workshop operations.
The depot-level facilities in England had become factories in their own right, stripping damaged Shermans to bare hulls and rebuilding them with replacement components shipped from American factories. Engines that Wood's crew had pulled in 30-minute swaps arrived at these depots, where specialized teams diagnosed failures, replaced damaged components, and tested the rebuilt power packs on dynamometers before returning them to supply channels. The system created feedback loops. Failure analysis from depot rebuilds informed factory production changes. Common problems identified in field maintenance led to engineering modifications. And the entire operation improved continuously through the kind of industrial optimization American manufacturers had perfected in civilian production. Lieutenant James Morrison's Sherman, Rolling Thunder, had been hit by German anti-tank fire in late July, penetrating the hull and killing the bow gunner. The crew evacuated, and recovery vehicles pulled the damaged Sherman back within hours. At a depot facility in England, workers stripped out the damaged components, replaced the whole section with a factory-welded patch, installed a fresh power pack and transmission, and had the tank operational again in 6 days. Morrison got a different Sherman in the meantime, one whose previous crew had been reassigned after their tank was knocked out. The crew survived, the tank was replaced, and the operational tempo continued without interruption. The system treated both men and machines as repairable resources, each flowing through appropriate channels to return to combat effectiveness. Technical Sergeant Robert Chen rotated back to a training company in August to help prepare new crews arriving from the States, men who would crew Shermans rolling off production lines where workers had never heard artillery fire. He told them about the maintenance system with an emphasis that surprised some trainees who expected stories about combat. The Sherman wasn't the best tank in the world, Chen explained carefully, but it was the best tank for the war America was fighting, a war where keeping 50 tanks running mattered more than having 10 perfect machines. He taught them the basic power pack replacement procedure,
explaining how they might need to help maintenance crews in emergencies, showing them the quick disconnect fittings and standardized components that made the entire system function. By September 1944, as Allied armies drove toward Germany's borders, the mathematical reality had become undeniable, even to the most optimistic German planners. American armored strength in Western Europe exceeded 6,000 tanks, with replacement rates that could absorb losses indefinitely, given the industrial base supporting them. German panzer forces had been reduced to fewer than 600 operational tanks in the West, their sophisticated engineering achievements now scattered across French fields and workshops as abandoned hulks waiting for parts that would never arrive. The tactical superiority of individual German tanks still existed in technical specifications, but warfare had moved beyond individual duels to industrial-scale operations, where system efficiency trumped machine excellence. Oberfeldwebel Heinrich Müller spent the rest of the war in a POW camp in Mississippi, working on a farm where the machinery, tractors and harvesters, broke down with predictable regularity and was repaired with the same pragmatic efficiency he'd witnessed in that French maintenance compound. American farmers didn't rebuild engines, he noticed, they swapped them. They didn't handcraft repairs, they replaced components with factory parts ordered from catalogs. The philosophy that had shaped the Sherman had shaped an entire industrial culture, one that valued keeping equipment operational over achieving mechanical perfection. He thought often about his Panther, that sophisticated machine that had spent more time waiting for repairs than fighting, and wondered if German engineers had ever asked themselves the right question, not how to build the best tank, but how to keep the most tanks running. The Sherman would end the war with over 50,000 units produced, serving with American, British, Soviet, and Free French forces, its mechanical reliability and maintenance simplicity, making it the default Allied tank despite its technical limitations. The Panther, representing the peak of German wartime tank development, would reach only 6,000 units produced, its sophisticated engineering forever hampered by the complexity that made it brilliant on paper and problematic in sustained combat. History would remember both tanks, but the war had been decided not by which was better, but by which could be kept running. And that question had been answered in muddy French fields, where mechanics performed 30-minute miracles, while their enemies waited days for parts that never came.